Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, connected to network cable for virtual network computing, serial cable for some data exchange, data acquisition, Raspberry Pi camera for an alternate view via VLC, and a band cable to this breadboard, as well as an Android tablet with VNC as well, showing the Pi scope. And of course on the breadboard itself this circuit with an MCP 3008 analog to digital converter, necessary because the Raspberry Pi can only handle digital signals. Light dependent resistor from fischertechnik. The support for the Raspberry Pi camera is also fischertechnik. An ordinary light dependent resistor. NTC, negative temperature coefficient resistor, and all is connected through these wires to the band cable using the SPI protocol, serial peripheral interface. And what I'm trying to do is, by means of Python and Pi serial interface, capturing the data and getting them to a log file. Also attached oscilloscope for SPI, it's different signals, and a probe to the Raspberry Pi for the serial interface, also on the oscilloscope. Worth noting for the Android tablet is that I tried to do the VLC, which you will see soon on the laptop, that it didn't want to connect to the VLC. It can connect to VNC, virtual network computing, as you can see. So why it doesn't want to connect to the Raspberry Pi stream, I don't know, maybe because the battery is too low. I am currently charging it, so who knows. I have the stream on my Mac as well, as I will show you. So why things work or don't work, not entirely sure. Anyway, let's go to the software side and see how things work out with everything that I want to capture or not. On the software side, using Fedora Linux, I have the window which tells that it is actually the VLC stream. So no Pi scope on this side. Then the window to run the Python code. This command idle is to start the editor, in which I have all the Python code. And this code shows that it grabs through SPI all the data, all the relevant data. This is the code for reading it through the analog to digital converter, ADC. Then further F-write and serial-write. This is for writing it over the serial cable, and this is to write it to a file. And that means that I have actually two files going to Octave, where I write it to another file, and Octave is the mathematical scientific language, programming language, vector based, and here I read it from the serial line, and I write LDR1 and LDR2 to a data file. And experience has taught me now that it isn't written until I stop the program running, or stop running the program, which is kind of odd, because if you stop running the program, how much data have you got? So that's something that I'm not quite sure of. And this is the Minicom terminal, and this is the address that I use for Raspberry Pi. So that's how things work. And then of course the oscilloscope. RS232 is for this line only. These lines are for SPI. So let's run it and see how things work out. And then alright, these are nice values. Then it was also nice if I have Octave stuff running. Ah, there we go again. I have to do something else. I am going to open a new tab, and I have to gain ownership of the USB interface. For some reason it recently quit using it by default. So change ownership, and I'm using USB 1. Alright, that should be enough. This is a nice thing that I set by using the print. So that is this is caused by serial write. This is not how it is grabbed by Octave, so that is confusing. And now I will have to end this. This is not being sent anywhere, just receiving only. And now it does run, and it checks if things are equal, and then writes to a file. And you can see in the meantime that things are being received over the data line as well as over the SPI. So I actually should change the time base to grab more insight. And this way you can see more detailed, but it goes quite fast, because if you look here, I have set it to maximum baud rate, and last time I realized that I have to set the baud rate here as well at the same rate. So now data is actually showing the way it should be showed. Anyway, let's see how things have gone with the data file. X should terminate, and that is my doing. If keyboard hit is an X, then break the while loop. So in here I have to find RPI FT MCP, yep, which is currently 637 on June the 13th, which is today. So and this is not what I expected, because where is LDR2? I know that last time it did do LDR2, so where is it now? If I look here, I see that LDR2 is being received, no doubt about it. But where is it in the data file? In short, it's not. So this is very strange. Apart from this, of course, I have something else to do. I want the NTC being captured, and something else as well. Well, of course, the VLC, which I want to show. So this, although this is showing with about 4 seconds delay, you can clearly see the LDR, the LEDs working, because I programmed it to show when the LDR value is higher than a value, some value. So that's nice to see. Another thing, and I have to move the camera a bit. You can see here, and I have to be careful because it doesn't show on the camera as clear as on as with the bare eye, unfortunately. But what can be seen is that the Pi scope is showing all signals nicely, but as far as the value right here, and that's pretty hard to see, unfortunately, with on camera. Other than with the oscilloscope, I can't set the baud rate. Not that I know, at least. So I have to rely on these signals. I can try to grab the camera and show a bit closer. Does this work? Yes, that does work. So it's the distance. So anyway, now you see both the Pi scope and the oscilloscope. And so the signals that you see on the Pi scope, which is internal entirely, is not really the same as on the oscilloscope, where it goes through SPI, the upper 3 lines and the lower 3 lines, at least. The 0 line on both the Pi scope and the oscilloscope are the lower line with the signals. So that is not really comparable. And unfortunately I cannot tell why. Anyway, let's go on with capturing the NTC, because it is right here, but it's not yet in here. So I have to define a string S3 which is MTC. And then I have to copy this part. Which is then S3 to be compared to data 2 for 3 characters. NTC, just 3 characters. Which also means, and this is, oh wait, I think I'm making a small mistake here. Or am I? String compare. 1, 2, 3, 4. Why am I comparing a 3-letter string with 4? That doesn't make sense. This is 3 and this is 4. And yet it does capture it because it's LDR1. But this says LDR, and this also says LDR. Anyway, it does capture it, as you can see, so I think that's good. And then I say here equal 3 NTC, and then this should of course be NTC. I already put it here. I'll say this is LDR1, yeah, this is NTC, and then this will be NTC. And this should write it nicely. Question is, will it? So I will quit this one, which showed the content of the data log, and run it with F5, and there it goes. And here you get NTC value. So I'll have to run this for some time, hopefully capturing it. In the meantime, it just goes on and on and on. This just goes on. That's very nice. And okay, timeout on the tablet. So let me change that a bit. Okay, and there you have it again. So then it may be nice time to take a look at the Mac with everything running on it. And this is, as you can see, the VNC on the Mac, where I have another instance of the PiScope running. All the data you can't compare now with the oscilloscope, but maybe clear now. And this is the data log, which is not on the laptop, but this is filled by the Python script itself. And this is continuously filled in. So what is the added value? Well, mainly space limitation. I can only see so much on the VNC On the other computer, I can see hardly anything on the tablet. It's a 10-inch tablet, so that's quite limited. And then another screen is quite nice. Can I see the VLC? Yes. And the VLC you can see here. So once again, the LED that is dependent on the value of this LDR. I think it is this one and not this one. But it runs nicely, and that's what it is about. Why the tablet can't capture this address, I am not sure. Tried a few times and then it says unable to grab stream. So, like I said, maybe because of the low state of the battery, which is currently charging. Anyway, it's nice to see. Maybe I can grab him to the end. If I knew how on a Mac keyboard go to the end, it would be nice, but I have no idea. Mac keyboards are very different. But anyway, that is a very nice view this. So as you could see, data went on and on. So now it is time to check for the data loss again. Quitting and check the data log again, where I expect, let's go to the end. Why does it only contain LDR? Why does it contain weird numbers? This is strange. So if I, NTC is not found. Has it been found anyway? I have to look at gelijk 2. This is no, I have to look at gelijk 3. So let's go look for that one. And I am not looking at it. So NTC is being received but was not equal. Nowhere is an equality to gelijk 2 or gelijk 3. That is strange. That explains something, but not all. So NTC is if this one is equal to data 2. So I have to, and I compare really strings. And since this one is clearly working, I know the algorithm is correct. So why is the rest not working? That is very strange. This is checking for 3, that's correct. This is checking for 4, also correct. And if this is correct, then the LDR is checking, is getting the value of these two. Is that correct? Oh wait. That is something I have to check out. Is this ASCII for LDR? Oh, that's a nice one. Let me check that one out. That means that I have to use other things, other elements to compare. And there's another mystery. Because this and this one and this one are actually correct, but and this is what I do not get yet. This part of the code is getting all ASCII, which is sent by the data line, by the serial line, converting to their ASCII values. So if ASCII is 50, if the byte is content is 50, then the ASCII value is 22. No, it is 2. Byte content 50 is ASCII value 2, which makes digit 2. ASCII is the digit you are seeing on screen. So the ASCII value, the ASCII is I. The ASCII can be an F or an S, T, R, whatever. That is ASCII. So here the byte values are converted into readable ASCII, which are then data 2. Hence, if I make here an S1 and I assign to it the string LDR, I can compare S1 to data 2, and it says, okay, I have a value. However, when I do the same thing here to LDR1, because I fill LDR1 with exactly the same procedure as I do here, I expect LDR1 to contain, for instance, 223, 246, you name it. Just the value that it is receiving in here. 251, 255, 223, 247, whatever. But what do I see? I see here the byte content, and the 10 is nothing else. The last two digits, numbers, is nothing else than the line feed. And where is the line feed coming from? Here. /n. Actually RN, but that is a new line carriage return. So this is saying start at the beginning of the line and then a new line. And this is the new line. Line feed. Which brings me back to the question, why don't I get an ordinary ASCII number here? Or in this case, just here, because it hasn't written LDR2 value or NTC value to the data log. So that's a big question. Why doesn't that work? So this is correct and yet it is incorrect. Oops. And considering the time to wrap up, and yet another reason to continue next time. Yep. And that's, like I said, the end of this video. So, one problem solved, kind of. but also one big mystery added, and I want to solve it. I have to solve it for my own. For now, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can also follow me via Instagram and Twitter. And a lot of my Instagram pictures get quite a few likes. So I know many appreciate it for whatever reason, being it photographic or interesting or whatever. Anyway, thanks for liking. Please show your appreciation also by making a donation via either PayPal or Wired. And for PayPal, I know you need to have an account, because, well, I can't set up just a click button yet. But very much appreciated if you do anyway. You can also become a patron, and depending on the pledge, may have your name mentioned on the website and or video. Website and video. For more information, please see under this video. Have a nice day, to be continued, and bye bye.